All right, just like with speed and acceleration, we're going to work on some problems with force. Now, remember that these are Newton's second law. So, Newton said that you have force, and that force is going to be directly related to mass and the acceleration of an object. So, this says this equation I just wrote is force equals mass, so how much something weighs, multiplied by its acceleration. And we looked, we did a little quick visual where I sat in a chair and Karina sat in a chair. And it took more force for her to move me than it took for me to move her. Because I have more mass. So it's going to take more acceleration. So it's going to take more force. So the higher mass you have, the more force you're going to need to accelerate that object. These are pretty simple problems. We're just multiplying mass and acceleration. Now, some of these problems, I think I ask you to find, well, we'll have to see what happens. But F equals ma. F is force, okay, and force is measured in newtons, a big N. Mass, in most cases here, are going to be measured in kilograms. And then acceleration, I spelled that wrong. Okay, is measured in meters per second squared. So let's jump in. The first thing that I want us to do is I want you to identify your variables and highlight them just like we did with everything else. So we're going to say force, mass, and acceleration. Now I'm going to highlight my force yellow, my mass in green, and my acceleration in blue. All right, let's look. It says use the formula above. Answer the following questions. Remember to highlight your variables. How much force is needed to accelerate a 66-kilometer skier at 2 meters per second squared? So we have, underline our numbers. We've got two numbers there. Now let's decide what those numbers are using those units. If we have kilograms, take a minute. What do you think that is? If you said mass, you are correct. So we're going to highlight that in green. Then we have another number, 2 meters per second squared. Take a minute. What number, what variable is that? Meters per second squared. If you said that's acceleration, you are correct. Now it's asking us here, okay, how much force? Do we know the force? No, we don't know the force. So what we want to do is go ahead and use this formula up here where everything is equal to force. F equals ma. Okay? Our mass and our acceleration. Now we can just plug this information in. 66 kilograms times, that little dot is times, 2 meters per second squared equals our newtons. I'll give you just a minute. Multiply that for me. 66 times 2. Okay? I got 132. Now, remember that our units for force are newtons. Okay, so we got, our answer is 132 newtons, or 132 N. I'll do one more with you, and then I'm going to explain how we need to manipulate the equation if we need to. So what is the force? We don't know force yet. Of a 1,000-kilogram elevator that is falling freely at 9.8 meters per second squared. So if we underline our two numbers here, 1,000 kilograms and 9.8 meters per second squared. Let's identify those variables. 1,000 kilograms, what do you think it is? Is it force, mass, or acceleration? If you said mass, you are correct. Let's highlight with our mass color. And then 9.8 meters per second squared. What variable is that? Force, mass, or acceleration? If you guessed acceleration, you're correct. So now, we have M and we have A. Again, just like before, we're trying to find F here. So F equals MA. So F equals mass, 1,000, times our acceleration, 9.8 meters per second squared. So our force is going to equal what? If you got 9,800, you are correct. Good job. So as you go through, make sure you're highlighting. You are figuring out what your variables are. Now, I'm going to go to the next page for some quick notes. Never mind. If we look at number 5, now I'm not going to solve this equation for you, but I am going to show you how to change around this F equals MA equation, okay, to help you find mass. So whenever we have two variables together on one side and we're trying to get one of them away from the other, we have to ask ourselves. So in this case, we're dealing with M and A. In this case, we say, okay, they're multiplied together because when two letters are together, they're being multiplied. So to get one of the letters away from the other, we have to do the opposite of the action that's occurring. So if two letters were added together, we would subtract them. If two letters were subtracted, we would add them. In this case, they're multiplied, so we're actually going to divide them. So we're going to divide A out of it because we want M by itself. So we're going to divide A, so it cancels on this side. But in algebra, what we do to one side, we have to do to the other. So A is divided over here. So our new formula becomes M equals F over A. So if the equation's asking you to find mass, then you can find mass by simply dividing F and A. Now, for some reason the other worksheet didn't load on this, but that's okay. If it asks you to find the acceleration, we're going to do that same process, except we're actually going to divide M out instead of A. So, M and A are multiplied here. We've got to divide M out so it comes off the right side. And what we do to one side, we do to the other. So our new equation is F divided by M equals A. So if you're trying to find acceleration, okay, if you're trying to find acceleration, then you can just divide by force by mass. So I'm going to write that up here in our equation section. Just in case you need those for later. I hope this is helpful. and continue working on this worksheet. When you're done, please give it to the sub to hand back to me. If you are a virtual student, so Eileen and Sue, please send a picture of them to me when you're done. Have an awesome day, and hopefully I'll see you on Wednesday.